In this demonstration, what I want to do is how to run a multivariate regression. In the previous two demos, I ended up using a simple linear regression model that contained one feature and one target. Now I'm going to work on creating a model that contains two features and one target. Here are some of the requirements that I need to fulfill. I'm going to be creating a model with the two best features to predict target, and that's going to be done. The two best features are going to be selected based off of the correlation matrix. Then I'm going to do a train test split approach with 30% going to the test set. And from there, answer some questions such as how many observations are going to be in the train set, and then what's the accuracy score of the model. And that's going to be done using the test set. And we can also do some predictions as well. All right, now I am going to grab some information from previous code cells. And to first, before I do that, what I want to do is figure out what the best features would be. Now, here are the variables that we're dealing with. Now, predicted cells didn't come with the original data frame. That's something I added previously from another demo, but we had TV, radio, newspaper as possible features predicting the target, which is cells. But what I'll do now is I am going to focus on those by running a correlation matrix. Now, let me just go ahead and drop the predicted cells just for the sake of clarity. And then I'll go ahead now and just look at the data frame and then do a correlation on it. Right. So here we have the correlation. And if I'm going to go ahead with my target being cells, we know television is pretty strong. We have a correlation of 0.90. The next one up would be radio. So I'm going to go ahead and I'm going to use that in my model, and then let's leave off newspaper. Now what I'm going to do here is I'm going to go ahead and do the X train, X test, Y train, Y test, and use the train test split function, make use of that. Now, when it comes down to the first array, it's going to be, my first array is going to contain two data columns, two variables. That means I'm going to open up double brackets here, and I'm going to put TV, comma, radio, right? And that will be my first array. The second array is going to be cells. I'm going to do a random, I'm going to go ahead and hit enter here. I can do that right after the comma for space. I'm going to do a random state, or better yet, let me go ahead and first do a test size, or it wouldn't matter for keyword arguments. I'm going to say 30% of that is going to go in to the test subsets, then the random states. Go ahead and put 100 right there. Okay, so I'll run that. Then I will now work on instantiating a model. Let me go ahead and call this reg2. It's going to be linear regression. That's how you would instantiate it. And then I'm going to use reg2 to now create the model with the data. And specifically, you fit it with the train. And let me go ahead and do a score on the train, even though I don't really have to do that, but it's a good idea to do, so just to compare that with the test. And all right, so here we have it. I'm going to run that. Here we have a pretty high R squared, right? So 0.90, it's pretty good. Let me go ahead now and do a score when I feed it new data, which is going to be the X test and Y test, right? I get 0.870, so pretty good, right? It's okay. This is normal for us to have a variation between the train and test scores. So it's fine. There's no significant difference here that raises any eyebrows, right? 0.87, and this is all based off of 30% going into the test. If we were to play around with this number, we might get different results. But let's see here. So how many observations are in the train set? Well, we can answer that question after we ran this cell. So let me go ahead and open up a cell put in that comment, put train.shape, and we can see that there's 140 observations in the train set, right? What is the accuracy score of the model? Well, the accuracy score, just the accuracy score when it came down to the train, right? So this is based off of train data. And then we also ran it when we fed our model with unseen data related to the test, right? All right, let's see here. What's next? Predict sales by entering average value for each feature in the model. Okay, now, since this is a multivariate regression that involves two features, it'll be a good idea to just examine how X-train looks like, right? So here's X-train. We got TV, radio, that's in this variable. And we have the data that was randomly selected for the X-train. And you know this is randomly selected because if you look at the left column right here, this is not a data column. These are the index labels to the original data frame. These are randomized. And this randomization is really important to be able to generalize based off of the model, assuming that you have good accuracy scores. Now, that means if we're dealing, let me go ahead and just put a dot head here. If we want to use that model that we created called Rig2 and do predictions off of it, then that means when I do these predictions, I would need to put two values now because my model has two features, right? So let me see what happens when I just put these two values here. So I'm going to put 213.4, and I might have to fix this, but let's see, 24.6, and that. Oh, no, I don't have to worry about that. So this is the warning. I can fix this warning. I've talked about this before in the previous demo, but here is the results of the prediction. We're saying that if the company were to have spent this much, right, 200, let's say roughly $213,000 in television expenses, and then $24,000 in radio, they would be able to generate 18,000 roughly in unit sales. Okay, so that's the approach that you would need to take when it comes down to predicting with a multivariate regression. You would not want to just have one value, right? Because in that case, you are going to get an error. And so you have to be careful when it comes down to that. Let me just go ahead and put in that other value, run it. Now to get rid of this warning, dealing with the feature names, really quick, it has to deal with the train test split. I should add the attribute right here when I was using this function to say dot values. And since I reran this, that means I'd have to rerun everything else below it to take effect, right? Right. So that's not going to show anymore because this is not a data frame. This is now an array, right? So now we have it in this format. I can't use that head method there. And then now when I predict, it will just return the unit sales amounts without that warning, right? Again, I can also use the coif to get the coefficients. And these are going to be now coefficients for both of the features. And it's in the order that I've placed them. So this right here is a coefficient related to TV. This is a coefficient related to radio. Now, if we want, we can compare how our model did. And I'm going to base this off of, when I do my comparison, I'm looking at the tests. When I fed the model, the Reg2 model with unseen data, I got a 0.87 accuracy score, which is the R squared, right? The variance explained by the independent variables. Now, if I go back to what I did originally, when I had a simple linear regression, and that's up here, and when I did the R squared for the test data, we got a 0.77. So 0.77, we did in fact increase make our model better when we added an additional feature, right? Because with the simple linear regression model that I discussed earlier, where it only had one feature, which is television expenditures, it had an R squared of 0.77, right? And then when I changed the model up and added two features, I got 0.87. So that's a pretty good increase when it comes down to predicting unit sales. based off of the expenditures for advertisement. Hopefully this makes sense. If you have any questions, let me know. Thank you.